Hello and welcome to the course on manufacturing technology theory and practice. Now, what we are going to demonstrate you is how to make a block ready with the hole and the surfaces, required surfaces as per the drawing that you can see here. So, in this drawing you can see that this is a block. In fact, this is the blank for this job, this is the final job, and here these are the surfaces, these two are parallel surfaces, these two are perpendicular surfaces, all right, and they are smooth. Now, there are two holes, the hole locations are given from this axis as well as from vertical axis, all right, and the distance between the holes can be found out. Then we will show you how to file these surfaces, how to make sure that these two surfaces are perpendicular to each other. Those blocks that I have shown it to you, that through which you cannot see the light, in that case this is perfectly aligned to the horizontal and so on. After that there will be marking. Initially you have to mark so that the hole can be drilled. So, there are two holes which are to be drilled, and on those two holes according to the drawing you can see that there are also thread. So, first the hole will be made with a drill, and I already told you that after the drilling the diameter of the hole will be slightly different than the diameter of the drill, and it is normally little more than the diameter of the drill because of the vibration of the drilling machine and so on. So, overall the accuracy of the hole is not perfect. So, therefore, to improve the accuracy we have to tap it, we have to ream it first. Sorry. So, using the reamer we will show you how the reaming can be done. In this case we will be using the hand reamer. After hand reaming we will show you how the thread can be cut in the internal thread can be tapped in these holes. So, there will be a tapping operation and how this internal tapping or the internal thread can be made. So, these are the operations that we are going to demonstrate you right now. So, as I said that first it has to be filed. So, to make sure that this dimension is perfect according to the drawing, and I have shown the drawing to you. So, they have to be parallel, absolutely parallel, and this dimension has to be according to the drawing. For this purpose this has to be filed so that the material is removed and this dimension can be maintained. So, initially since a lot of material has to be removed, so and it has to be done manually. So, manually Mr. Aman Singh will demonstrate. This is the vise. In this vise this job has to be mounted, and then it will be filed manually. First with the rough file, I have shown it to you there. You can see closely that this is a rough file and this is a double cut, all right. And after that when sufficient material has been removed, so the final material removal will be through the fine file. Okay. So, this is the finer one, as you can see, smoother one, and this smoother one will remove less material, but it will improve the surface finish, and this is also a double cut file. So, using both the rough and the smooth files we can actually make a very smooth surface of all these surfaces, and these dimensions can be maintained. So, the dimension between these two surfaces and the dimension between these two surfaces, as well as we have to make sure that these two surfaces are absolutely parallel, these two surfaces are absolutely in perpendicular to each other, and these two surfaces are parallel to each other. So, these are the things which Mr. Aman Singh is going to demonstrate you, and then the marking will be done for drilling the holes. Hole will be drilled in the drilling machine, there will be reaming, hand reaming, and then finally the internal thread will be cut with the hand tap. So, it will be first clamped in the vise, and while clamping make sure that this is kept absolutely horizontal. So, now this is the rough file. Okay. just mind it, for the safety purpose you cannot hold it this way, because in that case you may actually hurt your hand. So, we always ask them to keep the hand like this, so that even if it comes in there, hand will not be hurt, you understand that. So, this is the process that we tell the students, the way how to do that, and it has to be absolutely done on the horizontal surface. If it is done vertically, in that case you know that this will not be a flat surface, but this will be an inclined or the round shaped surface. So, now the rough filing has been is done, and then there will be fine filing. This is the fine filing. In fine filing you can see that much less material is removed, as I said, but the surface is smoothened. Surface is smoother than after it was obtained with the rough file, and then all the time it will be checked whether this is perfectly horizontal. After it is satisfied, you can see that there is no light seen, and therefore, it is absolutely perpendicular to the other surface, as well as it is horizontal, that surface is flat horizontal. Now, it is turned around, and the lower surface or the other surface on the opposite side, it will be similarly filed. This is the fine file, rough file, sorry, rough file, and this is the fine file. So, while doing so, you have to also have two checks. One, that is this is horizontal, then you have to make sure that this is vertical. Those two surfaces are vertical, this surface and this surface, and then you have to also make sure that this dimension is maintained. This dimension is given by the drawing. So, this dimension has to be maintained, otherwise if you do it more, and this dimension will be then less than given in the drawing. So, it will be useless. So, all the time you have to, those checks you have to do, that the surfaces are proper, as well as the distance between the two surfaces is according to the drawing. Now, it is that 90 degree it has been rotated, and again the rough filing is done. So, most of the material is removed in that case, and the check is done that this is perfectly flat. Then the fine filing to remove the bars, as well as to improve the surface, smoothen the surface. Then it is checked again that these surfaces are at 90 degree to each other. These two surfaces. So, if you do not see any light through this T square, in that case you can make sure that those two surfaces are perpendicular to each other. Now, the opposite surface, similarly it is rough filed. And then it will be fine filed, the same procedure which has been followed for the other surfaces, and then the checking. Each time you do that, you have to actually check whether it is horizontal and whether the two surfaces are perpendicular to each other, the side surfaces. So, they are perfectly perpendicular to each other, as well as what you have to see is that whether your this distance is matched. Okay. This distance has to be also according to the drawing that is given, and this distance has to be also checked that they are given according to the drawing that I have already shown it to you, that this is the dimension which is given and this is the dimension which is given. So, these dimensions have to be also checked. Of course, the vernier caliper is there. So, you can quickly check by reading the main scale and the vernier scale, and where it is meeting, these two scales reading is meeting, you multiply by the least count here, which is here 0.02 and so on. So, this has been already told to you in the PowerPoint presentation of the metrology class, metrology session, and then we have to mark that for making the hole. So, this is to remove the bars, because when the filing has been made, there are some small bars appearing. So, now it is perfect, it is now stop. Okay, now it will be marked. So, as I was telling that there will be some kind of a painting, or you can even use chalk for that, so that the marking will be visible. So, you can also use a white paint, so that it could be visible prominently. Now, this is the height maker, height checker. So, you check the height gauge using the height gauge. This is the 0 position, and then according to the requirement that is there in the drawing, that at which height you have to have the hole from one of the bases, that is either from here or from here, accordingly you have to make the marking. So, that it is 10 millimeter. So, you make the 10 millimeter in the height gauge and you just make the marking. So, this is the axis along which the holes will be drilled. So, that line can be visible. Now, it is a vertical line, one horizontal and one vertical. So, their meeting point will be the center of the drilling of the hole, where you have to drill the hole. Yes. 25. Then it is 25 from other axis. So, you from from distance to distance, from center to center distance is 25 millimeter. So, at a distance of 25 millimeter, he is marking. So, another center will be at 40 millimeter. This is as per the drawing I am telling you. So, accordingly you can see those drawings. Okay. So, this is the distance which is given, 25, 40, 10. So, accordingly he is setting up the and this distance, accordingly he is setting up the marking gauge, height gauge, and through the height gauge he is actually marking. Now, the marking is done, and you can see the marking is visible clearly, because it has been painted by the chalk, and here exactly the drill punch will be used and a point will be made here, where the hole has to be drilled here and here probably. So, by hand, this is the hand punch. Okay. Marking will be done at the center of the holes, each of these holes, like that. So, these are the two holes. These are the centers of the hole, where you have to make the drill the hole, and also there is a slot to be cut. So, that for slot cutting he is also taking the marking. The slot you can see here from the drawing. This is the slot that we will be cutting, because there is a sawing operation, and that operation also we will demonstrate you. So, these are the markings, and the centers are marked as well as the position for the slot is also marked with the help of the hand punch. Well, first of all, the job has to be mounted for drilling the hole. So, job has been mounted using the vise, and according to the drawing, the hole that has to be drilled is a tapped hole of 10 millimeter diameter. So, if you remember, as I was telling you, that when the hole will be drilled, the drill diameter has to be less than the diameter of the hole, because if you take the 10 millimeter diameter of the hole, diameter of the drill to make a hole of 10 millimeter, the invariably the hole diameter will be little more than the 10 millimeter, and you cannot meet the accuracy. So, therefore, the drill that has been selected here is 8.5 millimeter drill. Then there will be rimming done, then there will be tapping done, and finally, the hole will be metric hole M and the 10. So, that is how it is written on the drawing, the hole as M10, which is metric and the 10 millimeter diameter is switched on. Since the marking is already there for the center, so at that center the drill is touched first, and then it is given the downward movements for penetrating the workpiece, and the hole will be a through hole. And then it is taken out, the drill is taken out, it is switched off. So, one hole has been drilled. So, then the next hole has to be drilled then. Oh, this is 9.84. Okay, this is 9.8 millimeter diameter drill. So, that is for the another hole. With the same speed, the another hole is being drilled. The cutting fluid has to be provided, because there will be a lot of friction and there will be a lot of heat generated. So, otherwise the drill will be worn out very fast, and the accuracy of the hole drilled will be less, because of the high friction between the drill and the hole that is being drilled. So, now both the holes have been made, and as you can see that they are of different diameters, because the different diameter of hole, different diameter of drills have been selected. Okay. All right. Now, it will be hand rimmed. Stop. उसको rimmer holder बोलेंगे, क्या बोलते हैं? Well, now it has to be, the hole has to be rimmed, because the hole accuracy is not very high. So, that for that matter, for that purpose, this is the rimmer, and if you remember, I told you that in the rimmer we will have less number of well, the rimmer teeth are like that in one word. So, if you can see that rimmer, this rimmer particularly has 1, 2, 3, 4, 5, 6 teeth. All right. Normally, if you see, all the rimmers will always have even number of teeth. So, there are two purposes for that, and particularly the one purpose is that the rimmer being an accurate instrument, that means you have to basically use the rimmer not to increase, not to remove the material as much, but for the improving of the accuracy. So, you have to very accurately find out what is the diameter of this rimmer. All right. So, for example, if it is worn out, then the diameter can be decreased. So, before doing that, according to the requirement of your hole, you can actually measure the diameter very accurately, if only when they are of the even number. So, you can measure that this is the right diameter, and another reason for having this even number is that in here the force requirement is very not as much as in the case of the drilling, because the material removal rate is not high. Now, the therefore, the force balance is very important for the opposite teeth, and if there are even number of teeth, only then the opposite number of teeth will have the balanced force, and that is another reason why this number given in the rimmer is always even number. So, in practice you will see any rimmer, be it a machine rimmer, be it a hand rimmer, the number of teeth will always be even number. So, now this rimmer has to be fitted in the rimmer holder, this is the rimmer holder, and using this square cross section. Now, this will be held in the rimmer holder. So, this will be hand rimming. Okay. And by hand, using the hand, using the force, torque as well as the thrust given to the reamer by hand, this will be rimmed. That means, the finish of the drilled hole will be increased, and as you have seen that there is a cutting fluid has been provided. So, if you see the difference between this fluid and the fluid that we have used in the machine, you should understand that here the is oil based. Okay. You can see that there is an oil bit of oil which has been provided, because here the friction is more important. All right. So, therefore, the coefficient of friction has to be decreased, and for that the oil based fluid has been used, whereas in case of the drilling machine or the turning machine, it was the water based. So, because there both of course, the friction, but to a larger extent, that is the heat that has to be removed. So, now this is rimmed. So, that means, we can make sure that the whole size is accurate as well as the accuracy is as per the drawing. Okay. Similarly, now the you will be rimming the another or tapping. This will be tapping. So, now next operation is that this within here there will be internal thread. So, for that a particular tap has been selected, and by hand by providing the torque by hand and by providing the thrust, that is the penetration of the tap to the workpiece, the thread will be cut. Okay. This is the technique that is used, that you have to turn this to and fro, so that it can actually have a smooth exit particularly. That is it. So, the drill hole is now rimmed and tapped. Okay. So, this is the final tapping. No, this is intermediate or final? Intermediate tapping. So, tapping has to be done thrice. Once is rough, once is intermediate, and the final is the smoother one, where it is the perfect tolerances and the sizes, accuracy of the thread or the threaded hole can be maintained. So, this is the final tapping to have the final accuracy of the drilled hole. So, this is filing, he is filing to remove the bars from the top from both the sides, otherwise it will disturb the thread to come in. So, you can see that now the holes are made, and this hole is tapped and this hole is rimmed, right. Another hole is rimmed. So, this is a rimmed hole without any internal thread as per the drawing, let us say, and this is another hole which has a thread, internal thread, and you have seen the techniques how the holes can be drilled, can be rimmed and can be tapped, that is how the internal thread can be cut. Stop. Boliye. And the final operation as per this drawing is the sawing of this slot. So, this is as per the drawing. So, now Mr. Aman will make that operation and show it to you. So, again that is clamped, And while clamping, you have to, once again I am repeating, you have to make very sure that this is clamped absolutely horizontally. And this is the hand saw, and using that hand saw, and the slot has to be made. Slot is made. So, if you see, if you remember, I already told you that initially he has marked. So, this is the height of the slot, and the size of the slot, it depends on the, or rather depending on the size of the slot which is given in the drawing, you select a particular saw blade, all right, because this blade is making this slot, all right. So, therefore, the slot width has to be little more than the slot than the width of this blade. So, accordingly you select the blade, because this width will be given. Here this is just an example to demonstrate you that how it can be made, but it can be of different dimensions. It can be wider, it can be thinner, and so on. Well, now we are going to demonstrate the working principle of shaping machine. You can see the shaping machine here. As a matter of fact, I would like to mention the difference between the shaping and the planing, which most of you might be aware of. Nevertheless, in case of shaping, the small work pieces are made in general. So, in shaping, normally the flat surfaces are made, the groove can be made, fabricated, and a dovetail surface can be fabricated. Like for example, in this machine, what we will be doing today is this shape or this part. So, you can see from the drawing that in this part we have a flat surface, we have a groove here, and we have a dovetail surface. We will show you the part, then it will be clearer to you that the groove has this dimension. In the other section, other view, you can see that, and these dimensions are given, okay, height, breadth, and all the dimensions of the flat surface, the angle for the dovetail, and the groove surface. So, the basic difference in case of shaping and planing is in the quick return mechanism, because in case of planing, normally the bigger surfaces are produced. However, the kind of surfaces that we produce in shaping remains the same as in case of planing as well. Now, in shaping, the tool reciprocates. Tool is connected to the arm here, and this reciprocates to and fro, all right. And while reciprocating in one cycle consisting of going forward and going backward, this is one cycle. During one, or this is rather called the stroke. During one stroke, that is in forward motion and the backward motion, the workpiece is given the feed which is perpendicular to the direction of the movement of the tool, that is perpendicular to the direction of the actual movement. Actual movement means the cutting movement, cutting speed. So, the cutting speed in this case will be the stroke of this tool. Now, the stroke length can be changed depending on the length of the flat, length of the surface that you are covering, okay. And that can be done with the help of a mechanism we are going to show you right now. Now, in case of planing, since the surface is much bigger, therefore, for reciprocating the tool, the quick return mechanism becomes very big. in the sense that in case of shaping, since during the forward movement the material is removed and during the backward movement the material is not removed. Therefore, the backward movement is normally done with the tool picking up, okay, not removing the material and at a higher speed. So, the speed difference or the speed ratio in the forward and the backward movement is called the quick return ratio. That quick return mechanism by which the quick return ratio is provided, that here in this case it is the Whitworth quick return mechanism in case of shaping. While in planing, if you are going to make the same kind of a Whitworth quick return mechanism, the bull gear which actually which rotates continuously and which is giving the movement of the quick return the Whitworth quick return mechanism, that becomes very big. Therefore, the same mechanism if you are going to make for planing, where you have the very big surfaces to be machined, in that case the machine would have been very big. So, therefore, the quick return mechanism in case of planing is different than the Whitworth quick return mechanism used in case of shaping, and in case of planing it is the loose pulleys and cross belt system normally used. We are not going to show you the planing mechanism, the planing lathe or planing machine, but in this example of the shaping machine it will be very clear how the planing can be operated. Okay. And it is only that in case of planing the workpiece reciprocates instead of tool as in case of shaping, and the feed movement is given to the tool in the same direction perpendicular to the motion of the workpiece, reciprocation of the workpiece in case of planing. So, that is the basic difference in the case of the shaping and the planing, that in once again that in shaping the tool reciprocates and in case of planing the workpiece reciprocates, because the workpiece is very big, and therefore, in case of planing the quick return mechanism is different from the one which is used here, and in case of planing it is not the Whitworth quick return mechanism, but the loose pulley and the cross belt mechanism that is used. Now, Mr. Srinivaslu is going to demonstrate the operation of the shaper, that is the shaping machine, and as I showed it to you, the kind of surface or the kind of the part with the flat surface, with the dovetail surface, with the groove, that can be fabricated, that will be fabricated in this machine in front of you. Okay, Mr. Srinivaslu. All right, as you can see that when the machine is on, this is the reciprocation of the tool which is mounted on this arm, okay, and the feed is given to the workpiece. In each stroke, one movement of the workpiece is along the direction perpendicular to the direction of the reciprocation of the tool. Yeah. So, you have to mount the tool. Yeah. So, there are आप चला रहे हैं क्या? Oh, stop. Well, here we have two tools which will be mounted at the arbor or at the arm. So, this is the tool which is used for making the flat surface as well as the inclined surface for the dovetail surface, and this is the tool which is grooving tool. We have shown it to you earlier. This will be used to make the groove. So, this tool, as you can see, that this is very similar to the tool that is used in the case of turning. So, this will be mounted in this way and it will be reciprocating, as well as this is the grooving tool which will be mounted after this dovetail surface and the flat surface is made to make the groove. So, Mr. Srinivaslu is going to mount these tools one by one and he is going to demonstrate how these surfaces can be obtained. Okay, now, this tool that will be making the flat surface as well as the dovetail surface, this is being mounted. You can see that how this can be, the tool can be mounted. So, now you can start. So, this way you can adjust the height of the tool with respect to the workpiece, and the machine will be on now. So, you can see that there is a certain stroke length which is fixed depending on the size of the workpiece. If the size of the workpiece would have been bigger, then the stroke length required would have been more, and that can be adjusted. Okay, so, now you do that flat surface. So, here by this mechanism you can actually change the feed and the height. So, this is going in the cross direction. It is similar to the cross feed given to the tool in the turning, but this is given to the table where the workpiece is mounted, and this is for the height.
You can give height, right? And also depth.
He is trying to make the contact of the tool with the workpiece, with the flat surface of the workpiece, and then the depth of cut will be given. Now, the depth of cut will be given to the tool, that is, the tool will be lowered with respect to the workpiece. This is definitely a slower process, as you can see that in one stroke a small amount of material or the small width is removed, and it will take some time for the entire flat surface to be generated. Stop. Okay, now you can see that in each stroke, that is going forward and coming back, some material has been removed depending on the depth of cut that has been given, and a certain amount of material is removed. So, after each stroke, the tool is moving along the width of the workpiece for the next pass to happen and for the next width to be removed, so that the entire surface ultimately can be machined and the flat surface can be fabricated. And notice one thing, that during the backward movement, the time taken for the backward movement is less, because the backward movement is at a higher speed than the forward movement, since at the backward movement no material has been removed, all right. And during the backward movement, as I have shown it to you, the tool is lifted up if required. So, if the very high depth of cut would have been given, you could have seen that the tool is being lifted up. Here it may not be visible very well that the tool is still being lifted up while the tool is moving back. So, actually you can see that the flat surface is being made. Now, for showing for the demonstration purpose, this groove was made, this flat surface was also made, but again a final pass has been given just to speed up the process, but otherwise you understand that the same way the entire surface will be produced and then the tool will be inclined according to the angle which is given for the dovetail, which is 45 degree. So, it will be inclined at an angle of 45 degree to this side when the inclined surface will be produced, and at an angle of 45 degree to that side when this angle, this surface will be produced. So, that will be demonstrated to you right now, and after that how this grooving can be done, that will be shown to you. Tool head has to be moved and tool head has to be inclined at an angle of 45 degree, as I said. So, you can see that the arrangement is being made for the inclination of the tool, and the tool is being inclined, as you can see here, and there is a graduation, there is a scale according to which you can find out what is the angle of inclination, and the angle of inclination will be 45 degree, and then you tighten this and the tool is fixed at that angle, which is 45 degree. So, then the right hand side inclination of the dovetail will be completed by this. Afterwards, we will go for the left hand side inclination, and the entire dovetail groove can be made that way. Now, the tool is straightened up. See, the tool post has been inclined, as you can see, and the tool has to be straightened up, because tool cannot cut, as you understand, at that angle of 45 degrees. So, tool has to be exactly straight, that has to be made with the head inclined at an angle of 45 degree once again, and once again the same operation will be conducted, that is the tool has to be in touch with the workpiece initially, then the depth of cut will be given, and step by step the operation will be completed for the inclined surface of the dovetail. So, at this moment we are preparing actually the left side of the piece. We will be making the right side or the left side of the piece?
One side.
Right side?
Yes.
Okay. All right, on the right side of this workpiece. Yeah, he is ensuring that the tool is in contact with the workpiece, so that the depth of cut can be given and the surface can be made. Okay, the machine is on now and the depth of cut is given. You can see in the backward movement the tool is being lifted up, because the depth of cut given is little more than in the previous case when the flat surface was produced. And again similarly, after each stroke the feed is given to the workpiece in the direction perpendicular to the direction of the reciprocation of the tool. Okay, so you can see that the inclined surface is made, and similarly, if we rotate the head, tool head on the other side and make a 45-degree angle, then straighten up the tool. In that case, the left side inclination of the dovetail will be completed. So, now the tool will be inclined to 45-degree on the other side, all right, so that the left side inclination can be done. Again, according to the graduation on the scale, circular scale there, the 45-degree angle is determined and it is fixed. After that, the tool has to be straightened up. Yeah, now the tool is being straightened up with respect to the workpiece. So that it could be perpendicular to the flat surface of the workpiece. Again, the tool is to be made in contact with the workpiece initially, so that the machine can be switched on and the operation can go on. That will be very similar to the surface that has been made on the right side of the workpiece. So, now the tool is in touch with the workpiece, after which the machine will be switched on and the depth of cut will be given to the tool in the vertical direction. Well, and after that you understand that the process is going to be a very similar one in comparison to what we have done on the left side, because the feed will be depth of cut will be given. Now that you can see that the depth of cut has been given to the tool, and the tool has started removing the material on the inclined surface of the left side. Ek minute. Well, now next operation is the grooving, and that is the grooving tool as I have shown it to you. That grooving tool will be now mounted on the tool holder in place of the tool that was made for making the flat surface and the inclined surface. This has been mounted. This has to be set, and then it will tightened on the tool holder. So, as you understand that the width of the tool is equal to the width will be equal to the width of the groove, and that would be done in one pass. Only thing is that the depth of cut will be given, so that the depth of the groove according to the drawing can be made. So, it is just touching the surface from where the grooving has to be made, and then the depth of cut will be given, so that the depth of the groove can be accordingly made. So, this is by this way the tool is getting lowered down, so that the depth of cut can be given, and the tool is removing material along the length of the workpiece, so that the grooving depth can be changed, grooving depth can be increased. Now, as you can see that the groove is being machined, and once again the forward motion, during the forward motion the material is being removed, and during the return motion the material is not moving, therefore, the return stroke or the return motion is at a higher speed than the forward motion. Here the workpiece is not given any feed, as you understand, because we do not want any wider groove than the width of the tool. On करिए तो बोलिएगा. Well, here you can see the there is a purposely made window for demonstrating it to the students. So, here through the window you can see the quick return mechanism, which, as I mentioned, is called the Whitworth quick return mechanism. And here, as you can see, that there is a bull gear, all right, and there is a there's an arm which actually reciprocates the element which is there, as you can see, and during that reciprocation it actually goes like this, to and fro. So, here you can see that this is the forward motion and this is the backward motion, all right. So, when it will go like that, this is the forward motion when the tool will be removing material, and then from here to here it will come at a higher speed. So, the time taken for the tool to come from here to here will be less than the time taken for the tool to go from here to here, that is a forward stroke, and this ratio is the quick return mechanism. So, by changing this by changing the distance, this length of the arm, you can actually change the quick return the stroke, okay, that is the speed. So, that we will show you that how that speed can be changed by changing the arm length. Now, you have seen that this is being changed. Now, the arm length has been changed, and if we switch on, you can see that this is the stroke length has been increased. Okay.
Tool is coming up to here.
Yeah. So, you can see the stroke length has been increased, that means the bigger length of the surfaces can be machined. So, that can be done by changing the arm in the mechanism, as we can see. You can see the working principle of the bull gear and the arm and overall the Whitworth quick return mechanism. Now, we have shown you how the stroke length can be increased, but then also the speed of this, that means the how fast this will be moving, the ram will be moving, that can also be done. Here we have 3 speeds, that is 82, 48 and 108. So, depending on the position of this lever, we can actually have the higher stroke speed and the lower stroke speed. Let us say we will, for comparison, we will right now we will have 82 speed. Okay. Switch it on, and you can see that the stroke speed is changed, and this is an 82. That is 82 strokes per minute. Okay. And mind it, stroke, I will repeat, is to and fro movement together is one stroke. Stop, and then you change that to 48. So, now you can see that the stroke speed has been reduced to 48, and if you switch on, the speed is reduced. Stop, and then we will be changing to 108. Okay. Now, you can see that it is a faster stroke speed, and this is at 108 strokes per minute. That is the maximum one. Well, now we are going to demonstrate the working principle of a shearing machine. This is very important, as you understand, because we have the material that in the form of the plate that we can purchase would be very bigger in size. They will never cut you into small pieces and sell it. So, they sell in the very big pieces. So, we purchase them, and then according to the requirement we cut it in length and in the width. So, this is a hydraulically operated shearing machine, and since it is hydraulically operated, so you understand that the strength or the load carrying capacity of this machine would be very high. So, here you can see that this is the cutter which works in the principle of guillotine, and it moves downwards, and this is moved by the hydraulic cylinders inside the chamber here inside the machine. As the machine is on, the plate will be coming, the shearing plate or the tool cutter will be coming down, and prior to that we have to set the distance in the x axis, what is the length that you would like to cut in this, and of course, up to 4 feet of the width it can be cut here, and length you can adjust by adjusting this value. So, according to your requirement you can adjust the length and this width that you can take. So, for example, here we have taken a certain width. Now, the length is important for us. So, we can cut it in small pieces or you can cut it in bigger pieces, that depends on how much you are setting in the x value. So, we have the plate which the thickness here is 6 millimeter, but you can go up to 8 millimeter. Okay. So, up to 8 millimeter thickness of steel plates can be sheared off, and as you understand that the shearing force which will be required here, that will be very high, and therefore, the hydraulically operated machines are used. So, right now we will demonstrate you how this 6 millimeter thick steel plate, this is the mild steel plate, how this can be sheared off, and we will adjust the values of according to the thickness of this plate. Now, what is that adjustment that we have to make for the depending on the thickness? If the thickness of the plate is smaller, you understand that the shearing force needed will be less, and therefore, the distance between this plate and this plate, that distance has to be less, and as the plate thickness is increasing, that distance has to be more, and that adjustment has to be made by the handle there in the machine, and then the shearing process will be effectively performed. That will be we will show it to you right now. You can actually switch on now. So, this is the adjustment which is being made, and that adjustment, as I said, is the gap between the cutter and the stationary plate which is there, on which the plate, our plate to be cut is stationed. This is inserted, okay, and this will be according to the length that we have selected. Now, this will be on, and you can see that the cutter will come down and it will actually cut it. So, it will be clamped and it is cut off. So, the piece is segregated. So, as you could see that before the plate, before the cutter comes down, it has to be clamped. So, those are the clamps which are spring loaded. Those clamps will clamp it properly on the stationary plate, and then it will be sheared off by the guillotine or the cutter which is there. Thank you for your attention.